All right, Mr. Smith here. This is Algebra 2, Section 7.5. We are now working on properties of logarithms. So in Section 7.4, we saw the definition of a logarithm, how to convert from an exponential form to a logarithm, and vice versa. In this section, we're going to work on properties of logarithms, and these are going to help us to solve logarithmic and exponential equations. Okay, so these are very useful. And for you to be successful in this section, you're going to have these memorized. One thing to note, this says log base b of m times n, right? Log base b of m times n, and that equals log base b of m plus log base b of n, right? So that's the property here. When I have a logarithm and m times n is the argument, I can break that apart into two logarithms by the process of addition. Okay. I also briefly introduced this power property previously, right? If I have log base b of m all to the m to the nth power, then I can bring this n out in the form of multiplication, and it's n now times log base b of m. Okay. Just a little note here. Here are some common errors, just to be aware of. It's in your textbook, but those are errors. I just want to highlight those are things not to do. Okay. All right. So to apply these properties, here I see log base 4 of 3/7. Again, the 8384s cannot calculate this. The inspires can. But let's assume for now that we had no ability to use our calculator to do this. And they also give us two values here. They tell us log base 4 of 3, and they tell us what log base 4 of 7 is. Okay. In the olden days, you'd have to use a logarithm table, usually in the back of the textbook, and that's how you would calculate a logarithm. Okay. So, by our property, our second property, this can be simplified into log base 4 of 3 minus log base 4 of 7. Okay. And of course, now I know what log base 4 of 3 is. They told us that up here. That's 0.792. And also log base 4 of 7, they told us what that is. It's 1.404. And if I subtract those using my calculator, negative 0.612. Okay. For part B, I can consider 21 as 7 times 3. So I can break this log back into log of base 4 of 7 times 3. But from our first property on the last screen, this can be broken up into log base 4 of 7 plus log base 4 of 3. And again, from at the top of the screen, we know what log base 4 of 7 is. That's 1.404. And log base 4 of 3 is 0.792. And when we add these, we get 2.196. And so this is what log base 4 of 21 would equal. Okay. Yeah, so I broke up 7 times 3 from 21. Okay. And then again, they had to give us these values here at the beginning of the problem. So they gave us those. Again, this is just an introduction. Very quickly, we'll get on to using variables in here, and now the inspires aren't going to be as effective. Okay. All right, so I'm going to skip example C. And here are two examples. I'd like you guys to work on these presently. If you're watching at home, please pause the video and work on these. Thanks. All right, welcome back. On this first one, this first guy here, we want to break up 4 as 2 times 2. Notice you don't want to consider this as an addition. You don't want to consider this guy's a sum like 3 plus 1 or 2 plus 2. That's not how this process works. We need to consider it as a multiplication factor. So we break it up into our two pieces now by our property of logarithms. Of course, we know what log base 3 of 2 is from the top of the screen, and we'd use our calculators to do the addition, or our minds to use the addition. Now for part 2, you can break up 16 as 8 times 2, 4 times 4, but I chose to consider it as 4 squared. And now by using the power property says I'm allowed to bring this 2 out in front, and that is 2 times the logarithm of base 3 of 4. Okay, so by the power property, which is the third property on our property slide, we can rewrite this. And of course, again, I know what log base 3 of 4 is. That was the first number I calculated. So I just brought this in and there. And did the multiplication, and there we go. Okay? So now we're looking to apply these properties, these rules, on a variable expression. Okay? It's the exact same properties, just now we're using variables to get there. So, I have log base 6, I have 5 times x cubed all over y. So, this is going to be log base 6 of 5 plus log base 6 of x cubed minus log base 6 of y. And my goal is to expand this and to simplify it as much as I can. I realize that in some ways it looks more intimidating. Let me go through the properties, right? When I multiply two arguments inside of a logarithm, I can split those out into two separate logs by addition. When I divide two pieces inside of a logarithm, I can split that apart by subtraction. That's exactly what I have there. Okay. Now, I know it seems like, well, wait a second, both of these are getting divided by y. Why is it just minus y here? If you want, we could throw in a set of parentheses there to say, well, both of those are being subtracted by the log base 6 of y, but it doesn't change anything mathematically. Okay. So what I had initially and what I have there is correct. Okay. Now, this piece can't be simplified anymore. This piece can't be simplified anymore. But the log base 6 of x cubed can be, right? Because I have an exponent here. This can come out front. And so this becomes log base 6 of 5 plus 3 log 6 of x minus log 6 of y. And there's nothing more we can do there. That is fully expanded. Okay, so I will use two phrases or two verbs to indicate what I want you to do. What we just did was we expanded. Right, if I want to go the other way, right, assuming I gave you something like this, and I want you to, the word is to condense. I want you to condense it. Okay. And each one of these properties, each one of these expressions has an advantage over the other, just depending on what math we're doing and what we need at the time. Okay? Just as a question, making sure you're on this, what is the base of these logarithms? The base is 10, right? It's a common log, so we don't have to write it. And the first thing I want to do is I want to work on this term. So I'll leave everything else alone. And since there's a 3 out front, I can rewrite this as log of 3 cubed. Okay. And now by our properties, here I'm adding two logarithms, so it means if I wanted to combine it, it would be under the operation of multiplication. And here I'm subtracting log 9, so that would mean I'm dividing it here. So there we are. And now let's see if we can simplify 2 times 3 cubed divided by 9. So 3 cubed is 27. 27 times 2 is 54. Divided by 9 is 6. So this should be log of 6. Now, log of 6 is just a number, in the same way that the square root of 5 is just a number. So don't freak out. Log of 6 is a number. It's a decimal number, just like square root of 5 is a number. Now, if it was square root of 4, we would never leave it as square root of 4. We'd just write 2. And the same idea applies here. If this simplifies nicely to an integer value, then we should do that. Okay. However, log base 10 of 6 does not simplify nicely. If it was something like log base 10 of 10, log base 10 of 100, now those values are going to simplify nicely, and we should do that. Otherwise, just leave it log of 6. Just leave it log of 6. All right, so this is condensing. The previous problem showed an example of expanding. Again, both of them are making use of our 3 properties. We have 3 properties, and so I'd like you to try these 2 problems. If you're watching at home, please pause the video and work on these 2 problems. All right, welcome back. Hopefully you found some success in working on these problems. One thing to note, right, because this 4 is being divided, it should be minus log of 4. And because the x squared is also being divided, you'll see it's minus log x squared, except the 2 comes back out in front, so it's minus 2 log of x. But it is being subtracted, and it should be. All right, one other thought. I have a log of 7 here and a log of 4. Those cannot be combined. The only time I'm going to be able to add those things is if I have like a log of 4 plus a log of 4. Then I have 2 log of 4. Okay, that's the only time I'll be able to combine those, is if I have the same log with the same base with the same argument, the same number inside. All right, so log of 4 plus log of 4 would be 2 log of 4. That's the idea. All right, down here, this goes pretty simple, pretty straightforward, right? This 2 comes back up as an exponent for the x. So I get ln of 3 times x squared divided by y. And that concludes section 7.5, part 1. This is actually most of the section. I've just covered most of the section. So tomorrow's lecture should be a little shorter. Thanks for your attention. Have a good day.